Hello students, welcome to our channel CS Chemistry. In this channel, we are going to discussing about the topic Lewis dot structures. Most of the students having a small doubt in how to draw Lewis dot structures. In this session, the doubts are going to be resolved. Let's discuss about the definition of Lewis dot structures. It is the picture of bonding in molecules and ions in terms of shared electron pairs and octet rule. Let's see the some important rules to draw Lewis dot structures. First one is selection of central atom. The central atom must be having highest atomic number and least electronegative value, and size should be mostly large compared to the other atoms in the molecule. The central atom must possess highest atomic number, least electronegativity, and should contain large size. One exception is hydrogen and fluorine never be used as central atoms. Hydrogen and fluorine always acts as corner atoms in the molecule. For central atom, octet rule is neglected. It means central atom may possess 8 electrons or more, not less than 8 electrons. Central atom tries to remain in maximum covalency. Maximum covalency. What is covalency? It is the number of electrons pairs by an atom with similar atoms or other atoms in a molecule is called covalency. Let's see some examples for covalency. The covalency of oxygen 2 for sulfur 6, phosphorus 5, carbon 4. Corner atom must follow octet rule. Every corner atom contain 8 electrons except hydrogen. Hydrogen shows a diplet configuration, 2 electrons configuration. For charged ions, if positive charge is there in an ion, it will be on central atom. For example, H3O plus. This positive charge will be on central atom O. If negative charge is there in an ion, it will be on corner atoms. It will be on corner atoms. That is example NO3 minus 1. This negative charge will be on oxygen. Let's see some trick to find Lewis dot structures. Q, here a small formula, Q is equal to valency electrons of all atoms plus negative charge minus positive charge. Here Q means total number of electrons in the molecule or ion. Let's see another formula, that is bond pair electrons is equal to 2 into number of bonds around the central atom, right? Let's see how to count lone pair electrons. Lone pair electrons is equal to total electrons Q minus bond pair electrons. Here you get lone pair electrons. Lone pair electrons can be used as double bonds or triple bonds, not only to show dot structures. The lone pair electrons can also be used for to draw double bond and a triple bonds between the molecule, between the atoms. Let's see some examples for the clearance of this concept. For O2, we have to first calculate total number of electrons. Q is equal to valence electrons of all atoms. Here is only one oxygen atom. So 2 into number of valency electrons 6. There is no positive and negative charge in this molecule. So here you get 2 6 are 12 electrons. The total number of electrons in oxygen is 12 electrons. Let's count bond pair electrons. Bond pair electrons are 2 electrons. Lone pair electrons is equal to Q minus bond pair electrons. That is Q 12 minus bond pair electrons 2. Here you get 10 lone pair electrons. We have get 10 lone pair electrons. Then the structure will be oxygen. Here we have to put 10 lone pair electrons. 2, 4, 6, 8, 10. For NF3, we get Q is equal to the total number of electrons 5 plus fluorine having 7 3s are 21, that is 21 plus 5 26. Bond pair electrons is equal to 3 2s are 6 electrons. Lone pair electrons is equal to 26 minus 6. Here you get 20 electrons. Then the structure will be electrons. We have to place 20 lone pair electrons in this molecule. 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. Here the central atom got 2 lone pair electrons. Let's see some examples among ions. For NO3 minus ion, first we have to calculate total number of electrons. Nitrogen having 5 valence electron, oxygen 3 6 are 18 plus negative charge. The negative charge should be added when writing number of electrons. Positive charge should be deducted. That is Q is equal to 18 plus 6, 24 electrons. Bond pair electrons is equal to 6 electrons. Lone pair electrons 24 minus 6, that is equal to 18 electrons. Then the structure will be nitrogen, oxygen, 3 oxygens are placed. We have to write 18 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18. So we have completed 18 electrons. This is the structure of NO3 minus ion. H3O plus ion. Same. We have to write Q is equal to 3 plus 6 minus 1. Positive charge should be deducted. That is Q is equal to 3 plus 5 is equal to H electrons. Here bond pair electrons are 6 electrons. Lone pair electrons is equal to H minus 6 is equal to 2 electrons. That is O is the central atom, H are corner atoms. Here only 2 electrons, that is in lone pair, they should be added to on hydrogen atom because the electronic configuration have completed, that is duplet configuration of hydrogen atom completed. We have to try for the molecules H2, oxygen and ozone, and the for ions. This is for molecules. Ions की SO4 2 minus, CO3 2 minus. This is your homework. Message these answers on comment section. Thank you for watching this video, and don't forget to subscribe to our channel CS Chemistry. Thank you.